Current virtual human simulations only consider visual perception while modeling agent behavior. In this paper, we present an agent-based sound propagation and perception framework, enabling characters to hear, classify, and react to virtual sounds in the environment. The red agent draws the attention of the green agent by whistling from an appropriate vantage point. Sounds are hierarchically clustered and categorized based on a human perceived similarity measure. During an offline process, a sound signal is adaptively discretized in the frequency and time domain to obtain a sound packet representation. Each packet stores the amplitude and frequency range for a specific time interval. The discretization of sound packets is optimized to maximize the similarity of sound signals based on human perception studies to obtain a minimal yet sufficient representation of sound signals enabling a human-like perception. Sounds are propagated in dynamic virtual environments using the transmission line matrix method. We use an adaptive quad-based environment representation with pre-computed propagation values to improve computational performance without significant loss of accuracy. Our framework captures different acoustic properties including absorption, diffraction, and reflection. TLM is suitable for dynamic virtual environments with multiple simultaneous and overlapping sound signals. For auditory perception, the similarity of the received sequence of sound packets is compared with sounds in the database using dynamic time warping. When the received signal does not match a single sound with a high confidence, hierarchical sound clustering parallels the natural degradation in identification. Agents may recognize only a general sound category or incorrectly identify a sound signal due to propagation-induced distortions. A sound is clearly perceived at near distances and in open spaces, with sound degradation increasing the coarseness of the perceptual category. Due to obstacles in the environment and other agents. This illustrates that sound propagation and perception accounts for the dynamic scene configuration and is not a simple distance-based function. The heat map shows regions of accurate, approximate, and incorrect perception of sound signals. Our framework can be integrated with attention and behavior models to simulate autonomous agents that perceive and react to auditory triggers in the environment.
Ouch! I'm sorry.
An agent navigating a blind corner hears another agent and reacts to avoid a collision.
Excuse me.
Agents that correctly identify the triggered sound react by approaching the sound location. The green agent is shown herding a crowd by using sound triggers mapped to directional movement commands. We demonstrate the benefit of spread by integrating into a game application. The original game without sound perception involves a player-controlled avatar searching for and destroying enemy robots in a maze. Robots detect the presence of the player using a simple distance-based collision check. We disable vision and add robot hearing so that robots perceive and react to different sound signals in the environment. Robots hear a gunshot and retreat or attack depending on their health status. They can additionally cry out for the assistance of nearby robots by emitting a sound signal. The resulting gameplay is greatly diversified, as players can adopt a stealth mechanic to isolate and corner robots in cordoned-off areas where other robots are unable to hear them.